As our last speaker for the day, I have got great pleasure in welcoming Arthur, who is a member of the Infrastructure Group Committee. Those of you who have heard him speak before will know that he takes a playful and irreverent look.
Oh God, no pressure, no pressure.
I should say, at the world of IT within higher education.
Right, well, yeah, this is going to be really boring now, and I'm just like, come on. No, I can't log into my laptop. There we go. Right, are you taking that side, yeah?
Well, we'll see how it goes. I'm going to pace around because I need to get my steps up on my Fitbit, so it's not...
And as you'll see, we don't want to be too close together. So, for those that don't know me, I'm Arthur, so I am the Director of Infrastructure and Faculty IT at the University of York, and that means I do Infrastructure and Faculty IT, which is a bit random, but it's quite cool.
And my name's David Thompson. I'm the Head of Software Development at the University of York, and I work with Arthur sometimes.
So, the title is What Uses Infrastructure in a Serverless Age. That's not actually what we're going to talk about. That is a lie. What use are infrastructure teams in a serverless age? That's what we're actually going to talk about. Will patch servers for food? Is that your future? Yeah, probably. Welcome to your future. So, let's go for it. So in the same spirit as Nick, let's talk about what I've optimistically said as how we used to do development, and that star there is quite important because actually this is our day-to-day jobs, as we know. So we're setting up a new service. Nothing's there. Okay, so what happens? We're buying it in, or I get David's team to write it. So, okay, so we've got a server. Great. So we've put some stuff on it. And then we go, oh, it's not big enough, so now we split it. Now we've got a web server, and we've got an app server. I know we've got a database server, but now we've got 3 servers, so we've got 3 times the chance of failure. So this keeps falling over all the time, so that's not very good. So now we have more servers. We have another web server, we have another app server, but we've only got 1 database server because it's quite hard to make databases resilient. But we just gloss over that. We just pretend it doesn't happen, okay? Okay, but now we need a load balancer because we've got to get all the traffic to that. So we have more infrastructure, it's great. And now we need a test service, so we've got the whole thing again. Oh, but now I've only got 1 load balancer. So I need 2 load balancers. Now we're getting somewhere. Yeah, this is good. But now we need more, because we've got more services. I don't go 1 service. We've got loads of services. And more load balancers. And more stuff. And more stuff. And more stuff. And more stuff. And this is job security. Yeah? This is what's not to like. I've got to patch them. You've got to update them. You've got a capacity plan. You've got a VMware or Hyper-V estate to run all this stuff on. You've got a SAN that keeps running out of storage space and that somebody needs to babysit to make sure it doesn't run out of storage space all the time. It's awesome. Okay. Oh, and we've got more and more. So we know we're doing it wrong, so what do? Well, we just do the same thing again, don't we? Because that is how major IT projects work. And anyone that's read the descriptions of major government IT projects will know this. The private sector is just the same. I've seen wonderful stats that just say it's completely linear, that the bigger your project is, the more likely it is to fail. That's just how it works. But DevOps is going to save us. Yeah, I stood on this stage in 2015 and said DevOps is going to save us. And that's the dream. Dev and Ops sitting in a tree. It's lovely, isn't it? That's the state of DevOps slide, that if you Google state of DevOps slide, this is what you'll find. There's about 1 billion companies all offering stuff, and it's all ops. All of this slide is ops, apart from this little box at the left, which has got some continuous integration, continuous delivery. And who goes to DevOps conferences? Devs don't go to DevOps conferences. Devs go to development conferences, and ops people go to ops conferences that we now call DevOps. Whoopee, it's great. So we've made things better. The practices that we call DevOps are great. The automation, the testing, that's all good, but it hasn't actually fixed that divide.
And the next thing that's going to save us is buying stuff. So buying stuff is good. Like, there is no doubt that buying stuff is better than making stuff. Undifferentiated heavy lifting is a great phrase. Like, we're universities. Why are you making a finance system on your own? Is a really good question to ask yourselves. But often we buy a lot of systems and often they're not in our control. So we often buy vertical systems, different people in the university buy systems that you kind of find out about in passing afterwards. You go, oh, that's nice. And actually what happens is they need to talk to each other. And suddenly the value that you've saved with someone buying something goes because suddenly you have terrible integrations. Because procurement isn't driven by open systems policies. I pasted an emoticon in there. That wasn't trivial for me, so I want some credit for that. And people with enough knowledge aren't in the room. And this isn't a deliberate thing. People aren't trying to exclude you, but sometimes you're not present. And what that means is that, and you know, this is our context, there's a lot of point-to-point, database, brittle, hard-to-upgrade integrations. You know, you've got databases speaking to databases in legacy systems. It's really hard to change that. And more importantly, especially when you think about the future, is these vertical slices, these platforms. Is that a question, sorry? No, okay. It leads to inconsistent data, and when we talk about using data for innovation later, it becomes really hard when it's siloed in all these places. So buying things good, communication bad.
But it does mean there's lots and lots and lots of databases to upgrade, which is great. So that's where we're at. Everybody's grumpy all the time, and the world is beep, beep, beep. You know, working in IT, it's all good, isn't it?
But all the cool kids are moving to the cloud, says I, taking the words out of Arthur's mouth.
Yeah,
you know,
because, I mean, you've read the marketing brochures, I'm sure. The cloud is going to save us. The cloud is going to make everything better.
Yeah, and actually meme copying is a great idea for your digital strategy. If you're not sure what to do, just copy someone else's. So loads of people have done this. We should definitely do this. I've seen other people do this. I've seen it on the internet. It's great.
And in the HE sector especially, we all buy what everybody else buys, don't we? So we're now going to write your digital strategy for you, okay? Because you wouldn't want to write an original one, so you can copy ours. So let's do. But let's just get the complaints out of the way first. There's no such thing as the cloud, it's somebody else's servers. Well, yeah, that is true. That is absolutely true. But it's not relevant. If the way you use the cloud, and this is what we're going to talk about in a bit, is as a pile of somebody else's servers, you are doing it wrong and it's not going to be very useful. But also, and I'm arbitrarily picking on student record systems here, obviously, but also your BMS system, your door locks, your heating system, all this stuff won't run in the cloud because it's not designed to run in the cloud. So okay, so it's not going to run in the cloud. I reckon if you're 55 or over, that is a valid career choice. This picture was called COBOL programmer. Yeah, there's the ops equivalent of, well, we're just going to run this stuff until it dies. But if you're under 55, I don't think that's going to last very long. You look at the speed with which all this stuff is moving to the cloud. We're moving to software as a service. And the companies whose products aren't moving are being outcompeted by those that products are. So it's not even that you can choose to use a product that's on-prem because that supplier will go under because somebody else will do it better and cheaper. So this is not optional. You know, do you want to have a career?
And this is a familiar chart to most of you. You know, we are, yes, I laugh. We are enterprise. It's Friday afternoon, everyone. It's okay, we can swear on the screen. This is where we are. We are enterprise IT. We're not supposed to be over here in the innovation curve. It would be a bad idea for us to spend most of our time in the innovation curve. We're over here. We're at the bit where people go, oh, God, this happened. It looks really useful. We should probably do it. And that's kind of where we're at.
And it's not a bad thing being enterprisey. The good side of being enterprisey is that as an enterprise, when you do catch up over here, you've got resource and money and people to throw at a problem. You've also got institutional inertia that will stop you doing it. And it's how that tension plays out that will determine whether you're successful or not.
So this is us writing your digital strategy. What should your cloud strategy not look like is where we'll start, which is a great place to start. Do you do this?
Do you do this? Should you put your VMs in the cloud? Now, no. And I know we've had a talk from Plymouth earlier that says they've done. The only exception I would say to this is if it avoids you spending 15 million on a new data center. That is a great reason to put your VMs in the cloud. Okay, if you're avoiding building more legacy. But in general, I think if you take your existing kit and you shove it in the cloud and you run it in the same way, you've replaced one load of cost with more cost over here for no benefit. You have to do huge amounts of work. So you have to think very carefully about whether you do this and what your justifications for doing it are. And this is not where we've chosen to start because we don't think that's where the value is to be obtained. As I say, although I say don't do it, it's not always wrong, but be very clear about the reasons why you're doing it. And now to go to something that is always wrong. Containers aren't going to save you either. So everybody wants to do containers. Devs want to do Kubernetes, and ops people want to do Kubernetes because it looks great on your CV. CV-driven development is totally a thing. But it doesn't actually solve any of your problems. You've got a huge pile of moving bits in a Kubernetes server. It's a hard service to operate. Even in a cloud environment, these are not trivial things to operate. Doing it on-prem is just bonkers and you shouldn't do it. You've still got to update your images. You've still got to patch stuff. Now, if I had a 100,000 line, if I was an ISV and I had an existing big software program that I wanted to move to the cloud, then I would do containers. Absolutely, because it would get me there in the least way. But that's not the sort of code. How big's the average code that you write?
How big? About this big.
It's not hard to move. Yeah? So let's not do this.
And this also introduces a whole set of problems which you don't know about yet if you've not used containers before. You get into metrics, you get into security, and it's a different landscape from VMs or on-prem servers.
Yeah. You need a service mesh, I hear, and I don't even know what a service mesh is, but I hear we've got to have one. One exception, they're really good for science. Big science isn't quite as compute. Yeah, it's requiring lots of stuff. Containers let you do reproducible research, and in particular, how should we put this tactfully? Scientific code is often, should we say, optimized for time to paper rather than quality? Yeah, it's really not very good, but it doesn't matter because that's not what it's designed to do. So when people want to share this code, you have something that runs on somebody's laptop and doesn't run anywhere else. Or it runs on CentOS 6.2.3 only, and nothing later. We've got an actual case at work where we've got a code that's been given that somebody's trying to use that requires specific library versions that are 7 years out of date. It's really hard to get running, and this definitely helps. But that won't be Kubernetes, that'll be a HPC cluster running containers. And in case you're wondering what the relevance of the picture is, this is nothing to do with containers. I just really like the picture, and it's science, so we're putting it in. So this is Dr. Katie Bowman. You might have seen, I don't know oh yeah, there we go, just about works. That is the first image of a black hole. It was in the news recently. And this was the moment when the imaging worked. And it's like that moment. It's really cool, there's other pictures of here with her like stacks of hard drives like this, because there's just like so much data to do this. So this is a big HPC job. But science is cool. Containers will definitely be a thing for science. We should do them for that.
So let's talk about cloud native. We said we were going to write your digital strategy, so let's attempt to help you do that. So first of all, we stepped back actually, and we thought, what are we actually doing here strategically? Like, this isn't a tech choice, there's some principles we need to adopt here. So the first thing we really considered, and this is about leadership, and it's about managing large estates, was around evolution. We knew that change would happen at different speeds. There's no version of this where you go and turn everything off, and the cloud turns on and everyone's happy. Like, that's just not going to happen. You've got teams, you've got culture, you've got technology, and really managing that and knowing that it's going to happen at different speeds and what you do around training and people is really important. I've mentioned this before, but no one differentiated heavy lifting. We didn't want to put effort in where we wouldn't add value. So like doing stuff that had no value to students or staff or very limited value wasn't going to be top of our priority. It would be really easy to be like, let's make a data lake. Let's just do that because I heard this on the blog. And there's just no point if you're not going to do something with it. And this is, again, it's not real until it has users. Software only counts when it delivers value. So there's a real risk of cloud of you just going into this technical tunnel where you come out and go, and it's just not what it's for. We also, and this is partly learning the lessons of the past, we wanted to design for operability more than anything else. So we wanted security, controlled cost, so understanding what the cost profile would look like because it's very different in the cloud, availability, and just adopting the 12-factor principles for deploying apps, so stateless and all that kind of thing.
Just going to say one thing there. When David says undifferentiated heavy lifting, that means a lot of what ops teams do. And I think we need to be brutally honest about this. Nobody cares that we're running an elastic cache or an elastic search. That's not the value. It's a necessary bit of value in the old world for an ops team to run those stuff so that these guys can deliver user-facing software. It is not necessary in the new world, and that's what we'll come on to. But it's probably worth saying that this 12-factor thing, if you Google 12-factor software design, you'll come up with a list of principles. It's cloud-native design. It does not work for existing things. And again, this is part of, we're going to do the new things in a new way, and we're going to leave the old things where they are for a while and probably rewrite them. Because you can't take the old code and run it in the new.
One thing, and we just literally stole this from AWS, and it actually comes from, I think Gartner did it sometime in the 90s, this idea of 5 Rs. I think AWS added one because, you know, why? And this is how we approach our sort of legacy, and kind of legacy is even stuff that's written yesterday without tests, right? This is how we approach our estate. So, you know, rehosting, should we just put it somewhere else? Should we re-platform it? What does that platform look like? Do we need to modify our infrastructure? Should we not be running one of those and just buying one of those? The thing has been commoditized. The thing you made 10 years ago has gone. Just go and buy one. That's really important. Refactoring, like, is this a rewrite job? Is this something that the user needs have changed? The value isn't clear. Do we need to rebuild this? That's obviously like the dark path, which is weird coming from a developer, but it is. Retain, just leave it. It's been running for 20 years. You know how to manage it. It's expensive to change it. Just leave it for now.
That's basically every FM system ever.
Yeah. And retire, which means just like turn it off.
Yeah.
Managed, in a managed way. Yeah.
But those of you that went to the Plymouth talk, I'm sure those categories will seem very familiar, because that's what you have to do.
Definitely. So that's our decision process that we adopted, which has been super helpful. Benefits, and like this, I think when I did this slide, Arthur was like, did you just rob this off some generic supplier? But it's worth saying, he's not very
every
nice.
supplier ever always promises all this stuff, don't they? It's just like, it's going to be great.
Yeah, so actually these are real. These are the things that we've started to see in our transition. So the big thing is agility. Like, we've been able to move quite quickly and respond to different needs as the university sector has changed in different ways. You know, being able to spin stuff up, being able to experiment. You know, we're just starting to invest in a proper data pipeline project, and previously the lead time on that would have been huge. The procurement exercise would have been huge, and now it's not. Ease of deployment. The cloud lends itself to better practice around building isolated systems that you can tear out, and that's really helped us move quite quickly. Did you want to talk about scalability?
We've got an entire slide on scalability in a bit that we'll talk about under costing.
Yeah.
But scalability and performance, where it says through event-driven architecture, really what we're interested there is not so much the performance of any individual app as the fact that you can decouple your applications, and you can have a service bus and you drop events on a service bus. So your event might be, a new student has joined, and lots of applications need to know about it. And by doing it that way, you get rid of your direct database-to-database coupling. You create a whole pile of other problems. You know, there is no silver bullet. Fred Brooks said it in 1981 or whatever it was. But it is potentially better.
And it's genuinely helped us deliver value to our staff and students and to the university faster. You know, we've been able to move forward with our project and product roadmaps in a way that we wouldn't have been able to previously. And then the last thing is, you know, this is kind of an unexpected thing. Well, not unexpected, but as we've started to move data sources into the cloud, especially like master data sources, we've started to see how we can use and wire things together using a lot of the tools from AWS that you kind of gloss over when you're looking at the massive dropdown. And it's like, okay, this is interesting now. We can like do better stuff. And that's actually kind of exciting, really.
And we're going to talk about the specifics of this in a minute.
Yeah, definitely.
So with the cost thing, every time you go to any talk by any cloud vendor, they'll tell you, oh, you can scale up enormously. It's like, I don't care. I just don't care. They talk about, well, clearing, you must have loads. It's like, no. We've got the same 5 student record system VMs that have run there all year. They never change. They handle the load. It's fine. In the grand scheme of things, no university has any substantial load on any application. It's just not there. What we do have is loads of little systems that are actually useful. They're interesting, they're vital, but they might be used for a group of 5 people in clearing, so a couple of weeks. Or, you know, as part of the admissions process, there's this little thing. Or there's something that's used maybe all year round, but by a very small number of people. So these things are tinily, in terms of load, they're tiny, tiny, tiny. And that's where you get to exploit the cloud cost model. And this is why you don't do VMs in the cloud. Because all the things around, say, auto-scaling VMs in the cloud is you have a certain base load, because a VM takes a while to spin up. Yeah, it just trundles into gear, so you keep a base load. The base load is already too much for most of these things. And this is why we've gone the serverless route, because that actually genuinely scales to 0. So it makes this stuff very, very, very cheap. So we've got a data integration that actually, ironically, runs in a container. But it runs in a serverless container, or something called AWS Fargate, so we don't have any Kubernetes. The reason it's a container is that the ISV that we're working with gave us a container image to do data integration with them. So they've written a container image, we deploy it. We deploy it in our account, it spins up once a day on a cron job, it pulls data from our databases and shoves it into their system. That costs us 6 cents per month to run, because it runs for 10 minutes a day. Now that's a cost win. I don't care to say. Scaling up, meh, don't really care. Scaling down, yeah, now we're talking.
And we
right.
We thought we'd, wow, that looks really distorted from where I was standing. We thought we'd just give you an actual example. And again, I know some of you will already be probably further on your journey towards the cloud than we are, so apologies if this is patronizing or things you already know, but just run with it. Don't complain afterwards. This is just a really kind of simple app, but it shows some of the principles that we talked about previously in practice. So we've got a user obviously using a mobile phone, and this is a staff search app, so staff and student, directory application, let's find people at the university.
Yeah. What's Blogs' phone number?
Yeah.
You've all got one of these.
So they make us, and also I should count, this is a presentation architecture diagram. I don't know if you're familiar with these. Do not use this. Do not deploy it. It is wrong. The things aren't labeled. It's just for illustrative purposes only. And what they get is they get a static app, so just a JavaScript app that loads from Amazon S3, which is just a file system in the cloud. That's super cheap to run, like it's negligible. It can take infinite load if that was ever a problem.
Which is not.
Which it's not, because it's a university directory application. And then it speaks to a critical piece of infrastructure that Amazon provide called API Gateway. This is like huge, as anyone who uses AWS will know. It routes all of your URLs to do stuff, and it provides lots of hooks into monitoring the requests and everything, really. And what it's doing here is routing requests to a Lambda function. So a Lambda function, if you're not familiar with those, is just a bit of code that runs in the sky. What did you call it? CGI bin for the 21st century. Yeah, that's kind of what it is. It's not really that, but it might help you frame it.
But so if those of you that have been like Nick and myself around for a while, if you remember the old days when you FTP'd a pile of PHP code onto a server and it just ran, and then 10 minutes later it was compromised.
Yeah.
That's sort of the model. You don't worry about any of the application stack. So, you know, in the scheme, this is an infrastructure group. There is no infrastructure. You just tell it it's a Python runtime. It's Python 3.7. You give it some Python 3.7 code that takes data in this format and sends it on in this format, and it just runs. That's it.
And it runs on request, so that only spins up when something happens. It just lies idle the rest of the time. It doesn't exist. This performs the search, so we span up Elasticsearch, and this is a really good example of how easy it is to spin up infrastructure that previously would have cost time and effort. Obviously, it's not huge to spin up a VM. It's half an hour or whatever it is. But installing and maintaining Elasticsearch instances over time has a cost. Putting it in the sky means that essentially there is no cost associated with the maintenance of this thing at all. Do you know what I mean? That, really importantly, just serves the request back, because it's kind of a read-only cache, I guess, for the people data, which actually lives over here in the university on an Oracle database. You can see that my diagramming tool was so cool that it didn't really have anything for that. And then what that does is extract we've got a Lambda function here which runs like a cron job, just regularly, takes people data out and puts it into Elasticsearch. It's just a super simple, like, small app that we've made that kind of shows some of the principles. There's lines missing around here. We're using like a VPC, and there's loads of protection and firewalling and all those things.
That'll be infrastructure stuff.
Yeah, infrastructure stuff.
Which we'll talk about in a bit.
We'll talk about in a bit. But hopefully that shows how you can kind of quite simply hook stuff up.
So just to follow up a bit on this, you'll notice there's not a single server anywhere in this. This is an entirely serverless solution. So I think we should have a round of boos at this point.
Yeah, so throw stuff.
So as I think I've said here before, we've done a load of work on automating VMware provisioning. We can provision a VM in 10 minutes. So yeah, we're good at that. It's not like this is a process that takes a long time, but this is quicker. And the dev team did this without talking to ops. They didn't need to raise any tickets. They just span up a cluster. And the other thing is like the size of this whole thing. So how many lines of code?
I'll do that again. It's not very, all of these are quite small, so that's, it's 60 lines of code or something.
60 lines of code there, 60 lines of code there, a few hundred lines of YAML for the configuration.
A few thousand lines of
Yeah. We'll talk about YAML some more in a bit. But as a tiny thing, this is now great, because if we ever want to change this, well, we can change it. If we want to throw it away and start again, you don't get stuck in that sunk cost fallacy, because the sunk cost is so tiny. So how long did it take to develop?
So the team had little to no AWS experience at the time, so this was probably like a couple of months to get to kind of...
So a couple of months, including upskilling from zero.
And doing their day jobs as well.
Yeah. If you're an Azure site, Azure Functions does all the same stuff. Yeah. Other products are available, this is the stack that we're using. So that's what lots and lots of our data integrations, our small services will look like. It's a JavaScript app that talks to some APIs and does some stuff.
Yeah.
And it's all decoupled, it's all independent, and it's all really nice. So now we've written your digital strategy and we have solved all of your problems for you. I think we're done?
Yeah, I think that's it. Super easy.
Super easy. There's no hard stuff about this.
No.
So one of the things that people always say about this stuff is, well, you're locked in. You're locked into AWS. It's like, yeah, we are. And the argument that I would make is, you're always locked into something, and you just embrace the suck. So how many people in here use Microsoft, desktop technologies, Microsoft Windows? Show of hands. Leave your hand up if you could move off Microsoft Windows in any reasonable period of time. Wow, some people think they can. That is amazing. The choice is, which vendors do you wish to be locked into? That is your choice. It's not, do you want to have lock-in, it's which vendor. Okay? And I will just say that doesn't mean that we would only use one cloud. What it means is we won't try to be cloud agnostic. So we will use Microsoft Azure for Windows management, for example, because that is Microsoft stack, they're talking to Windows desktop, that just makes sense as a way to do things. But we're not trying to be neutral. And crucially, we're not trying to duplicate everything, because now you've got 2 times the ops work. Now maybe I'm making a mistake here, actually. 2 times the ops work, 2 times the staff, So pick your horse. The reason this is a donkey and not a horse is that all these major clouds, they are like massive. They are some of the biggest things ever built by humans. And when you use them, sometimes they feel like magic, and sometimes they're just not very good. So pick your donkey and stick to your donkey, because otherwise you're tied into something else. So lots of vendors will say, well, I'll sell you an abstraction layer over the cloud. So you can deploy workloads to Azure, you can deploy it to AWS, you can deploy it to Google, you can deploy it to Oracle, and you can cost bargain across these things and go where the workload is cheapest. Okay, great. So now I'm just tied into another vendor higher up the stack. I have not gained anything. And I've limited myself to the lowest common denominator of service. So I can't use any of the new tools. So I can't spin up the Elastic Cache because that might not be portable. I can't use the API gateway because that's definitely not portable. Yeah. Either do it or don't. And if you're going to do it, just pick one. They're all good. It's fine. But just pick.
Yeah, and of course what you get is another problem. So the other problem is that you've got loads of stuff suddenly to play with. We've said that developers can not talk to ops and make things, which is wonderful. But actually, there's huge amounts of risk in that. And we practically did a few things just to deal with that risk, and also to encourage the team to get involved and get trained and put the right governance in place. So a key thing was giving all the developers sandboxes. So a sandbox was their own AWS account, and we trusted them. Okay, we have cost monitoring in place every hour or something, but we trust them. They can do what they want. So if they want to go and rent a satellite or whatever AWS lets you do now with Ground Station, they can go and rent a satellite. We'd rather they didn't, but no one has, so it's fine. And that sandbox has been really key. People are able to make a mess, break stuff, try stuff out without having to kind of engage in like a production type environment.
This will never work unless you do that.
Yeah,
just for free.
Definitely.
We're good.
Governance has been really important. So we have a cloud architecture board, which we've got people sitting on from across the university, but it's deliberately not a gate. So there's no version of this where a team makes something and has to go through the cloud architecture board to get it shipped or released. Because we didn't want there to be like a team of experts slowing everything down. We wanted people to be able to release stuff. What it is an advisory body. We do stuff like example architectures. We deal with problems if they do arise, like if someone rented a satellite. And what else do we do in that group? Just
That's
governance,
most of
isn't
it.
it? It's pretty much it.
Policies, so we have policies around tagging. And the recommended architecture is a big one. It's like, if you want to do an API that talks to a database, then it should probably look like this, unless you've got a really good reason otherwise. And we just trust you.
Definitely. And then we've also adopted a bunch of practices that fit in with this kind of space. So we already did continuous delivery, but doubling down on that, doubling down on our automated testing so that we could release really regularly to production without worrying that stuff was broken. And it's actually worked to some value of.
Okay, last few slides. Security is obviously a big thing. In the cloud, you've just put your data on the public internet effectively. Making sure that it's not on the public internet or is properly secured is hard. Your developers will not always get this right because it's just hard. So in AWS world, they have something called Identity and Access Management, which is a language in which you write access control policies. It's really complex. It's really mind-bending. But it's mind-bending for the reason that it's trying to do a lot. So the Azure one is the same. It's quite hard. So someone has to understand that stuff. Okay? It's probably not going to be your developers. It's probably not going to be your security team. Probably means it's going to be ops. But your security team do need to be involved auditing, pen testing, reviewing. But really, as we say in the bottom point here, it has to be everybody's job. Everyone has to buy in, and you really, really, really have to do that. We all say that we're going to do this, but actually you really have to do it in the cloud, or you are going to have a bad time.
And this is really about a slide about inertia, and this won't be familiar to any of you. It was obviously just our problem, but it was hard to change stuff at the university. It was hard to introduce a new thing. Everyone, when they get interviewed, is like, "Oh, I love change. It's like the best thing ever." And then you sit down at your desk and like, "Nobody change anything. I've invested 10 years in learning how to do Java or whatever it is that you do." And it's a challenge because you're coming in and you're saying your role's going to change, the technologies you use day to day are going to change, the way you approach your job is going to change, and you need to be bringing people with you. They need to feel like they're part of the team. You don't want to be introducing like bimodal IT or something where you've got like, "Oh, we'll just put those people over there with the old things, they'll be fine, and we'll have an innovation team over here." You don't want to be doing any of those things. But yeah, that's a challenge for us for sure, but we've done all right.
Yeah. This does mean learning new skills for everybody, and it's a lot of new skills, and that's hard. And not everybody wants to do it, and that's the challenge. Because everybody says this and not everybody believes it. There's a lot of people in IT that don't want to change. I think we're very lucky that we have a lot of people that are really good and are learning lots of new stuff and are doing lots of new stuff. And once you get past a critical mass, you're away. So, identify your early adopters, bring them on. They will bring everybody else with you. Right, fade out. What are we all going to be doing? So, this is what you should put in your digital strategy, just to finally wrap it up. All your VCs are going to talks in which they're told everything is digital, software is eating the world, your organisation must be remade to be a digital organisation. And no one ever tells you what a digital organisation is or what it means, but we'll just gloss over that for now. But there's a clear corollary that core skills are essential for that. Digital is bigger than IT. Digital is about cultural change and process change and really reinventing your business. But if your IT can't change, you cannot do that. And certainly we've seen at York that every single major university IT change project hits IT. Every single one. So you can't outsource your way to success. That doesn't mean you shouldn't outsource some stuff. That's clearly you work with partners, you do things. But you can't outsource the core competency of your organisation. And digital is now your core competency. And therefore you need deep skills in it. So deep technical skills matter. Nick was talking about T-shaped individuals. So yes, think about the T, but think about the line as well. Yeah, you need both.
And it's a change for the university too, because what we're really investing in here is a capability. And I'm not just talking about programmers or ops people. You're investing in like a digital capability. That's the asset that the university is spending money on, not the transient systems or the transient cloud that it's using. It's your people that you're investing in.
We've ranted about bimodal, so we'll skip that one.
Done that rant.
Yeah. And the final thing on this slide, technical leadership is going to be key because, as we've said, if you pull that drop down on AWS or Azure or anything else, you just get a list of services like this. Who decides what a proper architecture is? Who is in your organisation can do that? Who has those skills? You need to identify those people and let them make the decisions. And you need to make sure they make the right decisions, which are obviously the ones that agree with everything that we're saying here and not any others. So,
Back to the talk.
back to the talk. This in the New World Order is what infrastructure teams might be doing, some of this stuff, lots of stuff. So all of this is automation. All of this is writing config as code. And I won't try and talk through all of these, but I'll just pick out a couple. Enforcing security policies, so the system can enforce quite a lot of policies. Development. So Mike over here, his Windows team write data integrations. So Windows Server guys are writing data integrations in PowerShell, which, yeah, it works. But leading culture change. I think that actually this stuff is easier for ops than devs in a lot of ways. So operations teams are used to this idea that you've got piles of stuff and it's all loosely interconnected, and a thing breaking over here can break something over here. Developers don't get that until they've tried doing distributed systems, because they're used to, well, it's a program and the bug is in my program. It's not how it is anymore. Now you've got all this data flows between things. But the key challenge is the and Wi-Fi at the end. There's still a day job to do because we haven't taken everything and lifted and shifted it. So the challenge for the leadership team within IT is, how do you give people enough resource to do this? And it might be, well, saying, okay, let's build this new project in a new way. And that means it's going to take longer. It might be, let's get new people into the teams. But one way or another, you have to create capacity to do that. So I think our final slide is what the job advert of the future for an infrastructure person might look like. How many people get the joke?
Nobody's.
So my new criteria for hiring is, if you get this joke, then you're in. All of this stuff in AWS is specified in YAML, and it's just like hundreds of lines of YAML. And that's it. That's how you do infrastructure now. It's a configuration language. It's not plugging into it. It's not even spinning up VMs. It's writing configuration. And that's what we're going to be doing. But we're not going to not have a job. We'll write YAML for food is not going to be a thing.
Perfect. I'm just going to go home and learn YAML now.
It's really easy.
I might have a job after that. I'm guessing you're happy for questions if anybody has any.
Oh dear, everybody's overawed where it's a little too late on a Friday.
No, everybody's been a little bit shy.
Cool.
Thank you, Arthur and David. That was
Thank
absolutely
you.
perfect.